Within this, we talk about ratios. So today is all about ratios and proportions. A ratio is a comparison of two or more quantities. It can be represented as a fraction, so A over B, where order does matter. Or I can say, so if I did use numbers, that'd be like 1 over 2. Or in words, so that would be A to B, or if I use numbers, 1, 2, 2. Or with a colon, so it's still pronounced or read A to B with a colon, but I could also write A or a 1 colon 2. Okay, what's important about this is you want to be sure to simplify. So if my numbers were 2 over 4, I would still reduce that down to 1 over 2. Okay, always simplify if possible. So let's go through some examples. So this first one, it says write the ratio in simplest form. There are 310 sophomores, 298 juniors, 302 seniors. What is the ratio of sophomores to seniors? So order does matter, and we will reduce. So sophomores to seniors. The number of sophomores is 310 over the number of seniors, 302. So we want to make sure that we are reducing this. I will show you 2 ways to reduce this on my calculator. And if you need additional help on your personal calculator, I can help you with that. So the first way is to write it in fraction notation. In this graphing calculator, it'd be pressing the alpha button, the green, y equals, and then enter, and then typing in the numbers, 310, and on the bottom, 302, and then enter. And then it will reduce my fraction for me. So it reduces it to 155 over 151. Another way to do that is to just type in 310 divided by 302. When I press enter, it'll give me a decimal. And then I'm going to go to this math key, click that, and then I want to go to a fraction, so I'll press enter twice, and then it will simplify that fraction for me. That is the second method. On some of your calculators, it'll say it'll look like this. You'll have that button somewhere, which takes it from a decimal to a fraction, and it will simplify. If you can't find it on your calculator right now, it's okay, I can help you find it. Questions so far? Okay, so the ratio of sophomores to seniors is 155 to 151. Now let's go juniors to seniors. This time I'm going to represent it as, let's use a colon. So juniors, there's 298, colon, to seniors, 302. I would reduce the same way. Maybe you can just guess numbers to reduce by, try to divide them both by 2, try to divide them both by 3, and see if you can reduce any further. Or type into your calculator, 298 divided by 302.
This one's dead.
Okay, just leave it there. Try another one. Okay, so this reduces to 149 over 151. So I can write it like that. I can write it like 149 over 151. Or I can write it 159, the word 2, 151. Questions? What I'm noticing right now is that both times I reduced, the seniors both got down to 151. So that tells me that we reduced each fraction by the same number. Okay, so for this next one, when I am comparing sophomores to juniors to seniors, when we have 3 or more, we just use colons. We don't use like 3-tiered fraction. So sophomores would be 310, to juniors 298, to seniors 302. When I reduce this, I can use the numbers that I was already given above because we just divided those by 2. So 310 became 155. 298 became 149. And 302 became 151. So that is our extended ratio. Questions? We're comparing our class sizes. So if I asked you what's the largest class size, either of these ratios could tell you, or the whole sentence could tell you, that it is sophomores. Okay, I called this an extended ratio because an extended ratio is a comparison of 3 or more quantities. 3 or more. We use those quite often when we're talking about triangles. It's written using a colon, such as A to B to C. Okay, example 2. Says the ratio of the angles of a triangle is 3 to 4 to 8. Find the measure of the largest angle, then classify by angles. So these are the measures of the angles. So they're 3 times as big as some number, 4 times as big as some number, and 8 times as big as some number. So I'm going to set up an equation. It'd be 3x plus 4x plus 8x equals, we're talking about the sum of the angles of a triangle. What should all of the angles add up to? 180, very good. So setting up the equation is new, but we're using some of the old concepts that we've learned. Combine your like terms. What is 3 plus 4 plus 8? 15. X equals 180. Divide by 15, so x equals 12. All right, so we found x. Now we're being asked to find the largest angle. So in this ratio, which one represents the largest angle? The 8. So let's do 8 times 12 to find the measure of that angle. What's 8 times 12? 96 degrees. There is a degree sign here, but if you want to write it out, that's fine. So now we need to classify this triangle by its angles. So we're thinking acute, obtuse, or right? Obtuse. Very good. Obtuse. Because one of the angles is over 90, obtuse. Okay. Number 3. The ratio of the sides of a triangle is 4 to 8 to 9. If the perimeter is 126, find the length of the shortest side, then classify by sides. What does perimeter mean again? The outside, adding up all of the sides. So if the ratio of the sides is 4 to 8 to 9, I'll set it up as 4x plus 8x plus 9x equals 126. Combine my like terms. What's 4 plus 8 plus 9? 21. X equals 126. Divide by 21, so x equals 6. Now I want to find the shortest side. Which one's the shortest? 4x. So 4 times 6, 24. And what are we talking about? We're talking about feet, so 24 feet. And to classify.
Wouldn't you have to do the other ones too?
We would not. So the question was, wouldn't we have to find them all to figure that out? We wouldn't, and who knows why we wouldn't have to. Logan? Say it again. Good, they're multiplying by different numbers here. So that's telling us that they're all different.
I thought it was angles. I thought I was stuck on angles.
So scalene, we got that. Ariana got that. So scalene, if this was isosceles, then it'd be something like 4 to 4 to 9. If it was equilateral, then it would be 4 to 4 to 4, or 8 to 8 to 8. But our ratio would represent that here. Questions? All right. Number 4. Number 4 has 2 parts, A and B. All of the information is given up here, though. It says the ratio of the angles of a triangle is 1 to 2 to 3. The ratio of the sides of the triangle is 10 to 17 to 20. The perimeter of the triangle is 235 inches. Solve for all angles and all sides, then classify. I'm going to give you a minute to set up each equation, and then we'll walk through it together. You do not have to solve on your own, but I would like you to set up. All right, Aiden, can you help me set up the angles equation?
1x plus 2x plus 3x.
Good. Our ratio given, and then setting equal to 180 because the angles should add up or sum to 180. Combining our like terms, 1 plus 2 plus 3 is 6x equals 180. Divide by 6, so x should be 30. Now when I find my angles, I have the 1x, that's the smallest one, so 1 times 30, 2 times 30, and then the 3 times 30. 1 times 30 is 30, 2 times 30 is 60, 3 times 30 is 90. How would I classify this triangle by its angles? Tate?
Right.
Right. Very good. All right. Now, who's got our sides? Cam, do you have your equation for your sides?
I have it, but I'm not really sure.
Not 100% confident?
I didn't know if to equal it to.
Okay, so give us your left side then.
10x plus 17x plus 20x.
Very good. So we've got those ratios.
Would I do it to 360?
Not 360. So these are our sides. So we're going to look for the other information they gave us
Or
about.
235.
Yes.
Yeah.
So they gave us that the perimeter is 235, and that's adding up those sides. So that's why we're going to set equal to that. 235. Good job. Combining our like terms, 10 plus 17 plus 20 should be 47x equals 235. Divide by 47, so x equals, what'd you guys get? 5. Then plugging that in, so 10 times 5, 50, and we're talking about inches. And then we have 17 times 5, what'd you get there? 85 inches. And 20 times 5, 100 inches. I could always double check. If I added these numbers back together, they should give me 235. Classify, raise your hand. How would I classify this triangle by its sides? Sebastian.
Wouldn't it be scale?
It would be scaling. Very good, because none of the sides are the same length. Questions? All right. The next piece, proportion. So this is a equation that states that 2 ratios are equal. It's written as an equation, so if I had 2 ratios or 2 fractions, A over B and C over D, making this a proportion to compare and say that they're equal would just be throwing an equal sign between them. We could solve for a missing piece or your x by cross multiplying. We can tell if 2 ratios are proportional by determining if they're multiplied by the same number going from left to right. Kind of sounds a little odd, so I'll show you what I mean. The first way to solve this example A, I'll show you two ways to solve. The first way would be to cross multiply, and I know a lot of you like to have your x on the left side, so we'll just make sure that we're multiplying the x piece first. So 11 times x, what's 11 times x? 11x equals 4 times 77. $308. Now divide that by 11. X equals 28. Very good. Here is another way to do it, which for this one works out really well. Sometimes, most of the time, it's not that easy. Okay, so we have a missing variable on the top. Do we know a number that will get us from 11 to 77 through multiplication? 7. If this is proportional, we'd be multiplying the top and the bottom by the same number. So if I do that, 4 times 7 would give us this missing number. Is 4 times 7 28? Yes, so it checks out. So that's another way we could do that. They're not all that easy. Most of them are not, but that's a great way to use this. Example B. This one's a lot like your warm-up. If I want to keep the x on the left, I'll cross multiply here, which will make me have to distribute. So that would be 2 times x plus 4 equals, now cross multiply over here. Some of you might have heard this called butterfly math in the past. 3 times 15 over there. Distributing, 2 times x is 2x, 2 times 4 is 8, equals 45. Subtract 8 on both sides, so 2x equals, I got 37.
Yeah,
37. Divide by 2. We're going to get a decimal, and that's okay. What's 37 divided by 2? 18.5. Very good. Questions? Okay. Why don't you go ahead and take a second. C and D. I'm going to let you solve those on your own. Note there are 2 binomials on C, so you'll have to distribute twice. And on D, you'll end up with x on both sides again. I'll let you take a second and solve those on your own. So part C, when I distribute or multiply, I have 3 times x minus 2 equals, cross multiplying here, 4 times x plus 3. Then I need to distribute. So 3 times x is 3x. 3 times negative 2 is negative 6. 4 times x is 4x. 4 times 3 is 12. Combine my like terms, so I'm going to subtract 3x on both sides. 4 minus 3 is 1, so just x. Then when I move this 12 to the left, I'll use subtraction because it's addition right now. So negative 6 minus 12 would be negative 18. Then for part D, 6 times x is 6x. 6 times negative 5 is negative 30. If you don't want to write it out with the parentheses and you can kind of just multiply it in your head, that's fine with me. Okay, you can skip that step. Then we have 2 times 2x is 4x. Moving our 6x to the left, so negative 30 equals 4 minus 6 is negative 2x. Then divide by negative 2, so x equals positive 15. Questions? Okay, flip it over. Last little portion here, we are going to determine if the 2 ratios are proportional. 2 ways to do that. The first way is to check and see what number we use to multiply, so left to right. So how did I get from 3 to 12? Times 4. Is 11 times 4 44? Yes. So it stayed consistent what we multiplied by, so yes, this is proportional. Sometimes it works out to be that easy and we have numbers that we're familiar with, factors that we're used to working with. And sometimes it's whole numbers like that. Where at other times, when I go from 3 to 5, can you think of a number off the top of your head that you multiply by? No, it would be a fraction, okay, or a decimal. So here's your other method. The other method is to set them equal and cross multiply and check if they're the same. So we'll do 3 times 17 equals 10 times 5. 10 times 5 is 50. That's a quick one. What's 3 times 17? 51. Well, those are not the same number. So no, these are not proportional. If those came out to the same number, then they would be proportional.
Can you divide like 3 divided by 10 divided by 17?
Good. Okay, that's a great thing to check. What Aiden was just saying, well, can I just divide them and see if they're the same number? So if I did 3 divided by 10, I get 0.3. And when I do 5 divided by 17, I get 0.294. Not the same number. That's another way to check. And when you do your, when we get further on in this unit, that's a good way to use this resource. If I did the same over here, 3 divided by 11, I get 0.272727, and then 12 divided by 44, I get the same thing. So that is another way to check. Now let's check here. I'll use that cross multiplying method. 3 times 31 times 53 equals 110 times 12. 31 times 53, 1,643. 110 times 12, 1,320. Are they proportional? No. They're not equal, so it's not proportional. Okay, then we have these ones here. So we can use a couple different methods. Cross multiply 65 times 12 equals 52 times 15. What is 65 times 12? 780. 52 times 12? 780. Same number, that makes these proportional. Okay, the last one is a real world example. There's a couple ways to do this. I will show you one method. There are multiple methods we could attack this problem with. It says, you are baking a cake that calls for 5 cups of flour, but you only have 3 cups. If you decide to scale back the recipe to change the amount of flour needed, how much sugar would you use if it originally called for 2.5 cups? So if we go from if we're going from 5 cups and we're going to, and even how we set up these fractions, there's a couple ways we could do it. We're going from 5 cups to 3 cups of flour. For the sugar, we're going to go from 2.5 cups to some number we're going to look for. Now, if we could easily see what we divided by to get from 5 to 3, we could, if it was just like dividing it by half, that would be kind of easy. This one's not. So let's cross multiply. 5 times x is 5x. 2.5 times 3 is 7.5. Now divide by 5. X equals 1.5 cups of sugar. My last class wanted to set this up, and they said, well, we went from 5 cups to 3 cups. And then over here on the other fraction, which number would they have to put on top? We went from 5 to 3. 2.5 would have to go on top to x. So that was just their ratio. They went from 5 cups to 3 cups, and then this is the ratio for flour, so it had to be the same ratio for sugar. We have different methods. Either way, when you cross multiply, we get 5x and 7.5. So it comes out to the same thing. Just depends on what your ratio is in your head. Is your ratio from your original recipe to your new recipe, or is it from your flour to sugar and flour to sugar? Questions for me?